It's no secret that more and more organisations are looking to build on their digital engineering and BIM capability. The AMCA and its members recognise the ongoing need to provide an industry-relevant solution through BIM-MEP AUS that is consistent in the right areas but flexible enough for consultants and contractors to deliver design and asset information requirements for the needs of each client and project. With that industry need driving our development, we are focused on continuously improving the BIM-MEP AUS template and the content. That is the way the 3D objects function plus the quality of the data sets. This approach aligns and builds on the broad goal of building information modelling, or BIM, to improve outcomes through better modelling and better documentation. You'll remember in the earlier session this morning, we saw how the BIM-MEP AUS product data templates are used to set asset information requirements before the modelling is commenced. In addition to providing product data templates for consistent asset information requirements, we've also maintained focus on the modelling and developed an entirely new Revit template, as we mentioned this morning. Another update coming this week on a new version of the template and focusing on updating our existing generic content and working with manufacturers to improve the way their content interacts with the BIM-MEP AUS template is something we're very much focused on. That also includes expanding the electrical content, and Christian will demonstrate our new cable tray with a built-in clearance zone shortly. We're extending the capability with PowerCAD, still staying on the electrical discipline, through families that contain the electrical functionality to work with that particular software for improving the electrical analysis of systems. Christian will also show you the updated generic pumps, our generic fan families, and as a result of our discussions with the manufacturers, as we mentioned earlier this morning, we've begun working with Grundfos to align some of their pump families to the BIM-MEP AUS specifications. Again, we're having more conversations with more manufacturers about the same thing. Again, Christian's going to show you a bit of a sneak peek at some of these families and the Grundfos content and what that looks like moving ahead for BIM-MEP AUS subscribers, and how that helps to streamline their processes, their modelling, their documentation, and speeding that up. So if you're a little unsure about the need to use an industry standard template and content, well, the main goal is primarily its ability to enhance collaboration with other organisations. So you heard some comments in the panel discussion around collaboration and standardisation and the importance of that. And it's really about resulting in improved outcomes for the project team and the clients. Now, that consistency facilitates a more efficient exchange of project models and asset information. You know, Sid mentioned it's about having the right information at the right time. And that works on many levels, from multiple consultants working together on large projects, consultants to contractors, multiple contractors working together, contractors with fabricators and other manufacturers, and even in the handover to the facility managers. It has the ability to share knowledge by incorporating the needs of others as well. So for example, I know through BIM-MEP AUS and the team at BIM-MEP AUS, we're always looking to improve and incorporate a level of constructability that's built into the content. And that's taking some of the knowledge and needs of the contractors and building that in to the content to allow others in the industry to model with that. You know, that ultimately results in more accurate coordination earlier in the design phase. Again, we've mentioned this a few times, but by establishing consistent parameters and pre-populated where possible with the values, that really streamlines the process to speed up and produce high quality documentation. So ongoing development, updates and maintenance is minimised because BIM-MEP AUS will do that for you. We also see consistent data sets and parameters allowing simplified analysis and reporting moving ahead and moving into the future. And for those organisations new to BIM, accessing an industry standard content like BIM-MEP AUS really accelerates that upskilling time and providing you with a ready-to-use template. It's certainly time consuming, and I think those who have developed their own templates certainly know this. It's time consuming and costly to develop your own template and standards. And then if you do, you're certainly restricted by not being able to connect as efficiently with others in the industry that are using that same standard. So that you know, there are a lot of points that were built into the BIM-MEP AUS concept and strategy, you know, from Warwick and the rest of the guys on the BIM-MEP AUS board, long before I was actually involved in the initiative in the early days with the original paper that was written. And those concepts and those you know, those points still hold true today. And lastly, a template and the content developed, you know, by industry, you know, with people with the most experience and you know, the type of skill sets that can really contribute to a leading edge initiative and content. You know, we saw earlier, everyone agrees at all levels that it really does make a lot of sense for the industry to use a consistent methodology. So just a little bit of background on what we're doing and what we hold true to how we develop and providing that, you know, that service for the industry. So what I might do now is we're going to move a little bit more towards a technical demonstration. I'd just like to introduce Christian Dorse. So Christian is with the University of Queensland, has been involved with BIM-MEP AUS for some time, and helps us with you know, some of the technical development and you know, as part of the industry work groups that we have to help with our direction. So welcome, Christian. I think you're going to take us through a template demonstration of the latest content and a bit of a sneak peek as to what's coming out too.
Yeah. Thank you, Shannon, for the introduction. Yeah, but also thank you to all the other speakers that we heard that morning, Sid from Autodesk and everybody on the panel discussion. Yeah, I think it got pretty clear, and Shannon, what you just said. We really need this industry standard. We need to standardize parameters. We need to standardize the information. Yeah, and this is also a bit the reason why we, as the University of Queensland, are also interested in seeing or maybe be a bit part of what BIM-MEP AUS, what the members of BIM-MEP AUS, of the AMCA are doing out there, because yeah, we're just not in that age anymore where we grab a DWG file and copy and paste a line work over into a UQ drawing. We really need your information. We really need the information from the industry. So this is really valuable information, and there's no chance for us as a university, as an organization, to collect all that data afterwards, after the project. Yeah, so it is really important for us that we have something like BIM-MEP AUS, have that set of parameters that we can just use across different consultants, across different manufacturers of assets. Yeah, this is why I'm so interested in working with BIM-MEP AUS. And yeah, I think that the BIM-MEP AUS template, the shared parameters, are a very good foundation for us here. And yeah, so in that first session that I'm doing here is we have a look at the BIM-MEP AUS template. Yeah, I'm going straight here into the software. I don't have any slides here. Will be pretty technical, as Shannon already said. Just very quickly here on the BIM-MEP AUS website, when you logged into the website, you should end up here on the dashboard, where you have access to, for example, the new BIM-MEP AUS template that we just that we created in June. But also, as already mentioned, the generic content, manufacturer's content. We will see that in a few minutes in my demo. And then in the second session, we will focus here on the fabrication content. Yeah, so I go straight into Revit and open that new template, and we have a look what's new in there. Yeah, just go open here. I have that new template. So I'm going to do that in the 2022 version. The Revit template will be available for 2000, or is already available for 2019, 2021, and 22. And the first thing we're going to see is the new start screen or the new start view here in the template. One of the questions that Shannon gets all the time is every time a new template is released, the question is from the BIM managers, what was the update? What happened in that new template? So that was not always very clear with the old template start view. So we try to improve that and have now some update information here in that start view, so that it should be very easy for a BIM manager when you get a new version of the template to really understand what was fixed, what is new, what are the major updates. So at the moment it is, of course, a new release. So there is not much of an update. So everything here is basically a big update. But in the coming updates, you will find a link here to the release notes or some informations about that new template. We also try to make the file version and the issue date a bit more clear, so that there is no confusion around the file version there anymore. Okay, the second view that we added here is a cheat sheet view. We thought it's a good idea that we maybe focus a little bit on some major features or some new stuff in the new releases. So, for example, here we have one of the two biggest improvements of the new template, the new pipe types that we will see in a minute, and the new cable trays with clearances. Just a very brief introduction into these tools, how you can use it, and just a bit, how should I say, a bit of a little, very little help document here. Okay, so I'll just go here into that sample floor plan. So this is something that you know from the old template. Yeah, so this is just a sample view where you can see basically everything that is in that template included. And we maybe just have a quick look at the new naming, or here on the duct systems. So this is one thing that we really focused on in that new template, that we have a consistent naming convention. So here, for example, when you have a look at the duct systems, that we have that abbreviation here in front, then a bit a description, and then the BMA here at the end. So in the old template over the years, it was not that consistent anymore. And as we already mentioned, the information, the quality of the data in the background is really important. And so we focused a lot on these things. Same for the pipe types, or for the pipe systems. We have added a couple of new piping systems in here, and they all follow the new naming convention, like the duct systems. Also, something that we added in that new template, let me go here, is insulation and lining, or new types of insulation and lining. So external and internal. Let me just have a quick look at the duct insulation. Just select that one, edit the insulation, so we get a bit of an idea of the insulation types we have in there. So we have fire-rated, MW, and foil-faced according to the BIM-MEP AUS specifications. And here in the lining, go here to edit lining. Also according to the BIM-MEP AUS specifications, the lining. I think very interesting for most people will be the new fittings, or the new duct fitting families. So we spent a lot of time also on completely rebuilding from scratch, rebuilding these duct fittings. Again, over the years, when that first template was created, Revit improved a lot, so there are new features in family creation that we just try to utilize. One of the strategies that we had in mind here with that new template was that we try to reduce the number of generic fittings to a minimum. And yeah, you will see that we have, for example, here when we go to that rectangular eccentric transition, yeah, so we don't have an concentric and an eccentric transition anymore. Yeah, we try to put that all together in one family. Yeah, because if you have an offset in there, it automatically becomes eccentric. We just have a look at that fitting. I just select that here. And you see if we go in there and change one of the values here to 150, so you see it automatically becomes an eccentric one. If I put that back to 300, it is a concentric one. Yeah, so we try to make these this fitting very, very flexible. Yeah, so we're not looking at fabrication parts at the moment. Yeah, so this is in the next session. Yeah, so our goal with the generic ones is giving the designer the flexibility. Yeah, so another thing that we have here, we don't have different families for flanged or not flanged. Another thing that we have added to all the families here is here a tick box where you can turn on or off connection or flange on connection 1 or connection 2. Yeah, if you have 3 connections, you would have here connection 3 as well. Yeah, again, something that we think we can easily put in one family. Yeah, another advantage when we just grab that fitting and maybe just copy it here over to the side. If you have these flexible duct fittings, let me put it a bit further down here. Just add a little bit of duct here on the left and to the right. So, for example, if you use here with that transition, if you want to use the justify command that we have here in Revit with that concentric family, or at the moment concentric family, we go justify, just change over here. That is my alignment line, and then I'll go finish. And I can use the same fitting here. For both situations, yeah, for concentric and eccentric situation. Yeah, maybe another example of the flexibility of the fittings in here. We have this breeches piece, rectangular one. Yeah, here we have that case that I was just talking about, that we have 3 connections on it. Yeah, and you can turn on or off the flange here if you want to show that or not. A bit further down, I can adjust here, of course, the duct width. We change that to 200 here, for example. I can have duct width 1, maybe 150. And of course, I can also change the angle here to maybe 30 degrees. Very, very flexible, I think. Another thing that we changed, maybe just go back here to that transition family. We have now a standard duct length for transitions of 800. So you see that one is basically locked here, a locked parameter. Yeah, but it's still possible to use something different. Yeah, it's just our default setting that we got a feedback from the industry that we should provide the standard duct length of 800, but we still can go into that family. We can switch here to lengths calculated. And once that is activated, that tick box, you see that we have here in the background an angle. Default angle here is 30 degrees. So the length of that transition will be calculated based on that angle. That would be one option. And we go a bit further up again. You see that we also have a duct length override Yeah, so if you have that box ticked, length calculated, yeah, you can make that a 600 transition if you like to. So yeah, again, I think very flexible families here, and it's pretty much the same for the others as well. All work in a very similar way. Yeah, so one family that we now changed from a fitting to a duct accessory is the step frame. So this is maybe something we should point out. So we think it is easier to use that step frame as a duct accessory, so that it can break into a duct run. So let me draw a little bit of duct here. Now I grab that rectangular step frame. Right click here, create similar. And now just hover over that piece of duct. And it breaks into the duct, and I can now change one side or add a lining to one side here, for example, on that side. Add lining, make it a 25 millimeter one, just pick the first best that we get here. And then I increase the size of the duct to 650. And yeah, works pretty well here, I think. Of course, what you can do as well, I mean, if you have that step frame, so we have out of the box, we have two step frame sizes for 25 millimeter lining and for 50 millimeter lining. So that means you have now, when you keep drawing duct here from that side, yeah, automatically that duct will then be 650 by 650, yeah, because we have that step frame set to 25 millimeters. Yeah, so this is that new step frame. Maybe we have a look also here at the new pipe fittings. It's pretty much the same. What I was just talking about here was the duct fittings. Yeah, we also try to reduce the number of pipe fittings to a minimum. Somebody in the industry called it the super families that we have created here. Yeah, that's basically it. Yeah, so this is really what we try to do. Yeah, because the more families you have, yeah, the harder it gets to keep them up to date, to make them work properly. Yeah, so we want to focus on a small number of families that really work well. Yeah, so here was just the example. Here was the pipe elbows. We have now that little elbow here, and when we go here into the properties, the different types of that elbow, so you see that with that single family, we can have 5 different materials or 5 different pipe systems that we support. Carbon steel, copper, PVC, stainless steel. The only difference that we have here in the second one is these are the flange connections, yeah, because we just have also added a couple of new flange specifications. As you can see here, table E, PN20, PN16, and yeah, so this was a bit hard to add that all into one family, and I think that makes sense to have a separate flanged family here. And the third one is here the welded connections that we have here. So these are more connection specific. When you have a look at the pipes, so we have sorry, not in the pipes. Let me just go here into manage. Another thing that we did here in the materials, we really created some new BIM-MEP AUS materials in that template, because I think that now was the improvement in Autodesk Revit. And also we heard it this morning, yeah, that sustainability and these kind of things get more and more important, and more people ask myself, for example, for energy parameters, energy values, and so we thought that it makes sense that we really build some really good proper materials here in Revit. So when you select, for example, metal aluminium, so you can identify the BIM-MEP AUS materials here, the BMA abbreviation at the end. So we also added physical and thermal values in here. So they are all coming from the Autodesk database, yeah. But we thought it makes sense to add them here into materials. I know that not many people really at the moment use that or focus too much on these settings, but I believe that in the near future we should have them ready. Yeah, because I think a lot of new platforms or other platforms, yeah, will pick up these values and can do a lot of things with that. Yeah, so this is also something that we did here. So then we have here in the schedule section, Shannon already mentioned that we, based on our BIM-MEP AUS shared parameters, we have created some schedules for pump centrifugal, for example. We have design, procurement, and commissioning schedules, same for the actual fan and air terminal units. So the design schedule is really for the generic parts. So when I open that one up here at the moment, so we don't see anything in here because we don't have any pumps in here at the moment. Yeah, but this is really the product data template that we see here, basically, or the level of detail, if you want to call it like that, what we expect in a design, or what the BIM-MEP AUS product data template specifies for the design stage. So let's just go back here to my sample floor plan and just load in a mechanical equipment, a generic pump. I have the generic content. And so now we have here the generic centrifugal pump. Just add a couple here of types to my project. When I place that one here now in my project and go back into that design schedule, you see that we have now that centrifugal pump in there. And with that generic family that you can get from the BIM-MEP AUS website as well. We already have a lot of parameters already populated. So here, for example, the electrical parameter that Shannon is working very closely on with PowerCAD. And all these families work in PowerCAD as well. So PowerCAD can pick up these values, yeah, and can reuse them in PowerCAD. So this will be the design schedule. When I go here into the procurement schedule, that family doesn't come up because we have added here a filter that is based on the manufacturer and the VBIS code. Yes, the VBIS code is needed to really filter pumps from actual fan, for example. But everything that is not BIM-MEP AUS manufacturer will be put into the procurement schedule. The design schedule just works the other way around. Here the filter is used to filter out for everything that has manufacturer set to BIM-MEP AUS. So this is just the little trick that we used here to specify between these two schedules. Yeah, so in the procurement schedule, you see that that one is empty. And Shannon already mentioned that very soon we will see some beautiful new content from Grundfos. And I have one family here that we now can also load here or via the mechanical equipment. I go here to that manufacturer specific content folder. And here I have the Grundfos family. We have already added the right BIM-MEP AUS parameter from the product data template to that family. So we go here to open. Again, here we have a couple of types. Just load in a few. I'm going to place that pump now here into our template. And go back to the design schedule first, so we don't see it here. Yeah, so here we just have that centrifugal pump, nothing else. But here in the procurement schedule, you see now the Grundfos pump here, Grundfos as the manufacturer in there. And yeah, also many parameters already populated, depending on what the manufacturer, of course, wants to populate and wants to add into the families. But yeah, here are also some of the electrical parameters already populated. Yeah, and this is really the big advantage here with using a standard like BIM-MEP AUS, yeah, that you can use different manufacturers, you can use generic content, and you have the same data in the background, the same information, the same level of information in the background. What is really what I already said for us as University of Queensland, for an organization like this, very important, yeah, to have that consistency. Because we maybe have an asset replacement and we need to replace a pump from manufacturer X with the pump from manufacturer Y. And I don't want to have completely different parameters on it, because this is just the Revit schedule. So that is pretty easy to handle. Yeah, but when you think of a facility management system that you have in the background somewhere that is connecting to these parameters, yeah, you can break a lot there. Okay, so this is the schedule. Yeah, I already mentioned the connection to PowerCAD. Yeah, that Shannon is working with Adrian very closely, what is good. Yeah, one of the big improvements here in the new template is the pipe types. I already showed you in the cheat sheet that we have something done there. Yeah, also according to the BIM-MEP AUS specifications, yeah, we have created new pipe types. So when we, or maybe just add a pipe straight away, maybe down here somewhere. When we have a look at the pipe types, so first of all, we have added the Victolic content again, like in the old template. So this is not something that BIM-MEP AUS created. So this is really just the Victolic content, but this is yeah, something that is just very popular. And yeah, but here we have the more material specific pipe types. So if you just want to draw a PVC pipe run or an HDPE, you just grab just the right material here. So copper press fit, yeah, and straight away I have, of course, that copper B schedule and the right fittings will be used. So this is not something brand new. But if you want to use something based on a safe working pressure, we have now created pipe types, and this is how the BIM-MEP AUS specification classifies these pipe types. You have here the safe working pressure, 1,400 kPa, for example, and up to the pipe size DN50, you can here in that case use a copper B braced pipe, but as soon as you come to a DN50 or larger, you should use a carbon steel pipe welded. And we can just use that here, for example. When I now start here with a small radius, like maybe 40. And so you see that here in the properties, the pipe segment that I will add now is a copper B pipe. And when I just add, or when I just go around the corner here, you see that we have now that the braced fitting. But when I now go to something 50 or above, you see that now here in the properties, you already see it. Yeah, automatically Revit changed to a carbon steel pipe. So I don't need to change that manually or need to draw a pipe and then change the properties. Yeah, so I just use the right pipe type. Yeah, and now when we go here and add an elbow, so you see that elbow is not a copper braced elbow anymore. This is now the carbon steel long radius welded one. And this is basically how that works. So you basically get the right pipes, the right connection, depending on the temperature, low temperature, medium temperature, or high temperature, and the safe working pressure. And yeah, you just need to select the right specification here, and Revit will automatically use the right the right fittings or the right pipe for it. Yeah, another thing that I wanted to mention here is the position of the connectors. So some people think that this is a bit weird how that looks. So our connectors sit inside of the fitting, yeah, because also some feedback that we got from the industry that many pipe fittings have the connector sitting here outside of the fitting, basically, what at the end means that you have the wrong length of the pipe. Yeah, so this is really what we did purposely, that we really have the connector sitting inside of the fitting to make sure that a pipe type that we schedule or that we use in quantity takeoff or we see in a quantity takeoff, that it is really the right one and that we don't miss 1 or 2 centimeters at the end. Okay, then the next big new update is the cable trays. Shannon also spoke about that, but before we dive into that, maybe a quick look here at the cable tray service types. So we also changed the naming a little bit here, added some new service types. That's not really a big thing. Here in the background, what we also did, we have some new cable tray types. Also, according to the BIM-MEP AUS specifications, fire rated, cable basket, cable ladder, different radiuses here predefined, 300, 450, 600, which was not the case in the old template. Yeah, so maybe we just use that cable tray here, and just draw a little bit of a cable tray run. Go here to the cable trays, and not just cable tray BMA. Yeah, start here an elevation of 0. Just draw anything here. Maybe go back up here. Maybe jump up 2000 millimeters. Add another elbow. Yeah, so just a little bit of cable tray here. Have a look at the 3D view. So, and another thing that many people in the industry requested, or where people were struggling with to get it under control, are the clearance zones around the cable trays. In the old template, we had basically a box, yeah, just a very generic box that you were able to align to a straight piece of cable tray. But of course, that was yeah, pretty hard, or didn't work for any elbow, for any bends. So what we did in that new template is that we now added a clearance zone to the fittings, not to the straights. So we just do it the other way around here. So every fitting, every cable tray fitting has now that checkbox clearance visibility. And when I tick that box on, and we get now that that visibility, that clearance zone around around that fitting. So of course that is a pretty flexible family again, or pretty flexible element, that clearance zone. So we have that clearance above the tray, so I can reduce that to 200. Can increase it to 500. Yeah, so that all works very well, I think. We have a clearance below the cable tray. I can increase to 200, and left and right of the cable tray that you can adjust 200. I can bring it further down. That one here, maybe back to 300. Yeah, so whatever, you're pretty free here. And the idea, or the strategy that we have here, is then to add that cable, or not a cable tray, the clearance also to that straight piece of cable tray. Only thing you need to know is basically the length of your cable tray here. I can just copy and paste that one. Select that elbow family again, and now you see that we have a clearance length A and length B. So what we basically have done is just added a bit of extension here to that clearance box or clearance zone, and I just increase, in that case, clearance length A, and that just stretches out that the clearance zone over that straight piece of duct. And I think this is pretty much easier to handle than trying to place that box family on each straight piece of duct. The other thing is that, of course, when you move now the duct left, right, that all is still sitting in the right place. Yeah, as long, the straight piece will always be connected to the fitting. So there's no chance that you can break that easily. Yeah, so we can do the same on the other side of that fitting. So another option that you have is go here into that into the properties of that straight piece of cable tray. So it's 3020, and just add that number here to clearance length B, and we have that clearance zone ready to go. Yeah, and I can do the same for, of course, for the other bands here. Another thing what I didn't do here so far is that, of course, we have different fittings here for the cable trays as well. Yeah, so you can always go and change to a square elbow. Yeah, that does also change the clearance zone. We have the tray with 2 segments. Yeah, so that is all much easier to handle than with a separate family, I think. Works in the same way here to the to that outside or inside band. We go in here, check that clearance visibility checkbox, and can put in the same dimensions here. So I think I had 200 there and 200 on the side. And yeah, works in the same way. Just need to find out the length of that straight piece, 1650, and I'd add that here to that straight piece. Yeah, and then we go on from here. Just add that one here, the standard size here. I put in a wrong dimension, I guess. Yeah, so of course that also works for, again, when you change that to the 2-segmented vertical inside or outside band. Works in the same way. Yeah, so I know that there are some people out there who'd love to have that even more automated, that whole process. But I think that family now, or these fitting families, are now the base to do further development. So I'm thinking of Dynamo scripts here that automatically stretch these families. That is maybe something that we will see in the future. So I think that is the foundation here for further improvement here in that area. Yeah, so these are the new cable trays. Yeah, just go back here to our top view, the top to the sample floor plan. We have conduits here. We have added some new conduit types. And we have a look here. We have now, other than the PVC one that we already had in the old template, we have now Austel and Telstra sizes or dimensions are standard. It's also something we went through many catalogs of conduits, and yeah, these were the 3 most common that we came across all the time. And yeah, we added these standard dimensions for the Austel and the Telstra conduits to that new template. Also, the system types here are exactly the same, like service types are exactly the same, like with the cable tray. All right. For the last thing I want to show here in that session is then our legend. Yeah, of course, we have again a legend in here as well. Yeah, this legend, of course, is also completely fresh, completely newly created, based on our new color codes, our new naming convention, the new duct insulation and lining types that we have, and pipe systems text styles, dimension styles.